do it in terms of u here. So d dx, the derivative of e to the u. All right, let's put over here where u is a function of x, okay? So where u is a function of x, so it doesn't matter what my u is up there. All right, it could be an x squared, 2x squared plus 5. It could be anything in there. All right, this is going to integrate to e to the u times u prime. So we're going to have a chain rule in here, okay? All right, because what would this, if this right here was a 2x plus 3, I'd have an outside function, I'd have an inside function, I'd have a composite function. So that's why I have to have a chain rule. So e to the u, u prime. All right, now I could write this formula with e to the x as well, right? Which I don't like those, but I can. So technically I could do this exact same thing as d dx of e to the x, all right, where that literally means x is x, all right? Well, if I apply chain rule on that, derivative of x is 1, right? So then it would just be e to the x. That's why I don't like formulas written with the x's, because then you can't see the chain. When I do this in terms of u and I say use a function of x, all right, then I can actually see that chain and I don't forget it, okay? But both those things are the same thing, okay? All right, so the derivative is pretty straightforward, pretty simple. All right, if I have a composite function, I'm going to use a u substitution. All right, or I could use a u substitution and then think it through. If not, you're going to get to the place where you just do this in your head, I think. All right, so let's do the derivative of e to the 2x minus 1. Okay, derivative of that. And I could put the square brackets in or I could leave square brackets out. All right, now this is a composite function. All right, so like I said, you can use a u substitution, but I'm hoping you can do this in your head. All right, if I were to let u would be that 2x minus 1, my derivative of u, my u prime would just be a 2. But since that derivative is that easy, that's why I'm hoping you can do this in your head. So the derivative here is going to be e to the u. So e to the 2x minus 1. All right, and then times the derivative of that exponent, which we said is a 2. All right, and then eventually you're going to get to the place where you're not even going to write that step. You're just going to automatically look at that, put the 2 in front, and go e to the 2x minus 1. Okay. All right, straightforward there. Okay, let's do, if that is a straightforward concept, it doesn't matter what my function is there, you take the derivative. Could I now, since I know this derivative, can I now put it in a function where I need to do product rule? Okay, could I do it with a function where it's like y equals maybe say x squared e to the x? All right, so now I can throw e to the x's into any of the equations that I give you. All right, so if I'm going to take the derivative here, I'm going to start with y prime, right? And then I'm going to do product rule. So I'm going to do the first term, which is x squared, times, now I'm going to go ahead and use our d dx notation. All right, so d dx, the derivative of the second function, plus the second function, times the derivative of that first function. All right, now granted, all of those derivatives would have been really simple, so I probably could have done it without the d dx notation, okay, but just to go all the way back to the beginning here, all right, x squared, all right, derivative of e to the x would be e to the u prime, okay, so just a plain e to the x, all right, plus my e to the x stays put here, derivative here is a 2x. All right, now at that point, I do want you to pull out your greatest common factor, all right, because what have we done so far up to now? What do? We take our function, we calculate the derivative, all right, and then ultimately, what do? We set that derivative equal to 0, solve for our critical points, all right, so same thing here. Let's get to the place where we're pulling out that greatest common factor so that it is easy to then set it equal to 0 and solve. All right, I've got an e to the x in both terms. I've got an x in both terms. So x, e to the x is that greatest common factor I'm going to pull out. That's going to leave me with an x there. E to the x with an x, that's going to leave me with a 2 there. All right, so we definitely want this answer. All right, because now if I had to set that equal to 0 and solve, Do you see why I was wanting you to solve exponential equations? Because when I got to go one step further and I got to find my critical points, that's going to be important. Okay. All right. Now,